A taxi is traveling at a speed of 25 meters per second when a traffic light that is 40 meters ahead changes to red. This diagram shows what's happening here. We have the taxi and the traffic light. The distance between them is 40 meters and the taxi is moving towards the traffic light at a velocity of 25 meters per second. So it's 25 meters per second. This is the diagram that we will be using for this question. So question 3,1 says define the term acceleration. Acceleration is the rate of change in velocity. Okay, so acceleration is the rate of change in velocity. The word rate means we are dividing by time. And what are we dividing? We are dividing the change in velocity. Okay, so in other words, acceleration is equal to change in v divided by change in time. That's what acceleration is. Then let's move on. They then say the driver takes 1 second to react before he slams on the brake. The taxi then stops within 2 seconds. So the 1 second was the reaction time of the driver. This is the time whereby the driver is deciding whether he should stop or he should continue moving. Then by the time he decides to stop and then presses on the brake, it will take 2 seconds for the taxi to come to a complete stop. Okay, so let's move on. Question 3,2 says, is the velocity and acceleration of the braking taxi in the same direction as it moves towards the traffic light? So the key point is braking taxi. Whenever we are braking a taxi, it means that the taxi is slowing down. And for something to slow down, it needs to experience a negative acceleration. So in other words, the acceleration will be in opposite direction to the velocity. So the simple answer is no, because it's only 1 mark. So for this question, the answer is no. That's it. Let's move on to question 3,3. They say give a reason for the answer to question 3,2. The reason is simple. Firstly, we have to say the taxi is slowing down. And it experiences negative acceleration. Therefore, acceleration is opposite to the velocity. That's our reason. The reason is that the taxi is slowing down and it experiences negative acceleration. Therefore, acceleration is opposite to the velocity. Okay, some of you may be confused that we mentioned negative acceleration. How is the taxi experiencing negative acceleration? We were told that from the moment the taxi brakes, it took 2 seconds. Okay, so from our question here, it took 2 seconds for the taxi to come to a complete stop. and it was traveling at a speed of 25 meters per second. So 25 meters per second will be our initial velocity, and the final velocity will be zero because the taxi will have stopped. So it would be stationary at the time. Using this formula of A equals to change in V over change in time, we can show that the taxi experiences negative acceleration by saying, let's use a different color for this one, by saying A is equals to change in V over change in time. Our change in time is going to be 2 seconds. So acceleration is going to be equal to change in V means final velocity minus initial velocity. So the final velocity will be zero because this taxi would have stopped by that time. Then the initial velocity is going to be 25 meters per second because it was traveling at 25 meters per second. So 25 divided by the change in time, we say it is 2 seconds because it took 2 seconds for the taxi to come to a complete stop. So it will be 2 seconds. A is going to be equal to, at the top there is going to be negative 25 divided by 2. So A is equal to, let's bring in our calculator, negative 25 divided by 2. Our answer is negative 12,5. So the answer would be negative 12,5 meters per square second. With this, we have shown that the taxi experiences negative acceleration because the direction of the acceleration is negative. Therefore, it acts on the opposite to the velocity of the taxi. Let's move on to the next question. Question 3,4 says, calculate the distance the taxi travels during the reaction time. Now, the reaction time was 1 second. We need to know how far the distance, and they say the distance. So we need to know how far the taxi traveled for that 1 second. So let's calculate. For this question 3,4, let's use a blue marker. For this question, we are going to use this formula. Change in x is equal to a big open bracket, final velocity plus initial velocity divided by 2 multiplied by the change in time. So let's substitute the information that we have. We are looking for change in x, which is the displacement. Open bracket, the final velocity will be 25 plus the initial velocity will also be 25 because during the reaction time, the driver was not pressing the brakes. So the taxi was still moving at 25 meters per second. Divided by 2, then multiplied by the change in time. The change in time would be 1 second because his reaction time was 1 second. So multiplied by 1. Change in x is equal to, we don't need a calculator for this one. So on top, 25 plus 25 is going to be 50. 50 divided by 2 multiplied by 1. Change in x is going to be equal to 50 divided by 2 is going to be 25 multiplied by 1. 25 multiplied by 1 is going to be 25. So the change in x is going to be 25 meters. Now, in our question, notice that they said they are looking for distance, not displacement. Therefore, we are only going to put the magnitude and not the direction of the displacement. So the final answer will be during During the reaction time, the taxi covered a distance of 25 meters, of 25 meters. This is our final answer. So 25 is our final answer. To question 3,5. Will the taxi stop at the traffic light? Show all calculations. For 5 marks, they are asking us if the taxi will stop at the traffic light or will it pass the traffic light. So for this question, we are going to calculate the total distance that the taxi covered from the time the driver notices the red light to the time the driver has brought the taxi to a complete halt, which means the taxi will have stopped and no longer moving. Let's calculate the distance that the taxi will cover once the brakes are being applied in that last 2 seconds. So we say change in x is equal to a big open bracket, final velocity plus initial velocity divided by 2 and then multiplied by change in time. The change in displacement is what we are looking for. The final velocity is going to be 0 because this taxi would have stopped by that time. So the final velocity is going to be 0 plus the initial velocity was 25 meters per second. 25 meters per second divided by 2 multiplied by 2. The change in time is going to be 2 seconds because from the time the taxi driver slams the brakes, it will take 2 seconds for the taxi to come to a complete stop. So this will be 2. So we go down and say change in x is going to be equal to 0 plus 25 is going to be 25. So 25 divided by 2 is going to be 12,5. So the answer is 12,5 multiplied by 2. 12,5 multiplied by 2 is going to be 25. So the change in x is going to be equal to 25 meters again. So the change in displacement would be 25. However, in order to find the total distance covered by the taxi from the time the driver sees the red light up until he comes to his complete stop, we need to add the distance that the taxi covered during the reaction time as well as during the braking time. So the total distance covered is going to be equal to the distance of reaction time plus the distance of the braking time. In the previous question, we calculated the reaction time distance to be equal to 25 meters. Now, in this question, we calculated the distance covered during the braking time to be 25 meters as well. So 25 meters. Therefore, the total distance covered by the taxi from the time the driver notices the red light up until he stops is going to be 25 plus 25, which is 50 meters. When we look back at the question, they said the traffic light is 40 meters ahead. And this taxi traveled 50 meters. This means that the taxi would not stop at the traffic light. Instead, it will pass the traffic light. So the final answer is going to be no. The taxi will not stop, not stop at the traffic light. At the traffic light. At the traffic light. Instead, it will pass the traffic light. The traffic light before it stops. So that's our final answer. Let's move on to question 3.6 says, draw a position versus time graph for the motion of the taxi. Okay, let's draw a position versus time graph. So whenever they say position versus time, know that the position is going to be on the y-axis and the time is going to be on the x-axis of the graph. So let's sketch the graph. Question 3.6. Position time graph. Always write a heading for all your graphs. This is our graph. Now let's label the information that we have. So this will be the time. The x is going to be the time. And you write the units, so it will be seconds. And then the y is going to be our position. The units are going to be in meters. And then here we need to write the point of origin, which is 0. Then we'll have 1 second there. 1 second. We'll have 2 seconds as well as 3 seconds. Then for our positions, we will have the 0 position and 50. We have 50 as well as 25. We said that, now let's sketch the graph. We said that the driver took 1 second to react. And during that 1 second, the taxi had traveled or covered 25 meters. So we will come to 1 second here. And then we go up at exactly the point whereby we are level with 25, we are going to put a point there. During the braking, the taxi covered a distance of 25 meters again. So the total distance will now be at 50. And all of this took 3 seconds. So we come at 3 seconds and then we go up. Whenever we are level with 50, that's where we are going to put our second mark. Now we only just need to connect the dots. So we start from 0, connect that point. Then we go on further to put a small curve that will go up until it reaches 50 there. That's our position time graph.